Today's topic for discussion is properties of OLS estimates. So in our earlier lecture, we have discussed thoroughly how the parameters are estimated through OLS, ordinary least square method. So now we'll discuss what are the properties of the least square parameters. Now, to examine the properties, we'll have to go for choice of the estimates. So, we know that there are various methods of estimation. So, we'll have to choose one which will give the estimates as close or nearer to the population estimates. So because we'll have to draw samples, and suppose population is very large, due to paucity of money and time, it is not possible to take the whole population as samples. So we'll have to select some samples within the population. So the estimates of the sample should be close to the population parameters. So this is examined with the help of mean and variance of the parameters. Now, there are certain assumptions that large number of samples, so sample size should be large enough. So for small sample, generally, the parameters may be biased. That means difference between the estimates of population and estimate of sample may be wider or higher. As a result, the precision will not be good. So we will need large samples. Then we'll have to compute the estimates. This is the estimated beta, that means from each sample. So suppose we have selected set of samples, so 1 to n1, then 1 to n2, like that, set of samples, then estimate beta from each sample and for each method, and form their distribution. Then compare mean and variance for each distribution and choose one which is close to population. So for each method, we'll have to compute the value of beta for each method and for each sample. Then we'll have to select the one which is close to the population through mean and variance and distribution of the parameters. Then the small sample properties. So samples may be larger or samples may be smaller. The small sample properties, they are unbiased. So we'll have to select on the basis of unbiasedness. Then least variance. Variance should be the least. Then it should be efficient. And base linear unbiased. It is called blue. We will discuss it in details later on. Blue. And least mean square error. That is, it is called MSE. And sufficiency. So number one, the unbiasedness. So expected, the estimated beta, and this is the population beta, actual true beta. That means true estimate and it is estimated. So their difference, mean of estimated and true, should be 0. So there should not be any difference between these two. Then secondly, least variance. Least variance is the estimated, this is the variance of the estimated, and it should be less than any other estimate of the parameter beta. This is, sometimes you call it arbitrary. So this should be less. This will be the least. Or variance beta A, that means estimated beta, should be less than variance this. Now, sometimes we see that it is unbiased with small bias and large variance. So this, if this happens, suppose variance is large but it is unbiased, but sometimes it is biased but variance is very low, very less. So in such situation, then we will have to go for the mean square error method that we will discuss later on. Then efficient estimator, unbiased with mean and variance. So it is estimated beta if it satisfies number 1A, expected beta, expected estimated beta, that means the mean of this is equal to true beta. If they are equal, then it is unbiased and efficient. That means unbiased with minimum variance. Then secondly, that is condition B, that the difference of beta head minus expected beta head square, that means the variance, should be less than this beta star expected. That is the another estimate of the parameter beta or arbitrary beta. So this should be less than this. So that means beta star is another unbiased estimate of true beta. So it is a minimum variance estimator. So next will be the best linear unbiased estimator and least mean square error, as I said, MSE and sufficiency. We'll discuss. So next is minimum mean square error estimator. It is known as MSE, minimum mean square error estimator, mean square error estimator. So it is said that it is the combination of unbiasedness and minimum variance. So it has the MSE estimator has the smallest error, mean square error. It is said that the MSE estimator has the smallest mean square error. Now what is mean square error? So it is defined as the expected value of the squared differences of the estimator around a true population parameter. So population parameter, suppose beta, and estimated is beta head. So the expected values are the square term. So it is the MAC is equal to MAC of estimated beta is equal to expected beta hat minus beta squared. So it is the value of the squared differences of the estimator around the population parameter. So this is, as I said earlier, that it has the smallest mean square error. Now, sufficient estimator. It uses almost all the observations of the sample. So, what sample we select, it uses all the observations, and parameter is as good as population parameter. So, what parameter will get out of it? Say it is called akin, almost similar to population parameter. So there is no much difference. It is said that no difference is left for others. Now parameters will not change if the trials are repeated. So parameters are so good that if the trial is repeated, suppose with different samples, trial is repeated with different set of samples, then parameters will not change if such trials are repeated also. Now, goodness of parameters will be obtained if, number one, it possesses more of the properties. So, when the parameters will possess more of the properties, so we have discussed about 5-6 properties. Then OLS, the blue estimates, we discuss later on in details. You will get in PDF also. So if it possesses most of the properties of the parameters, then it is the goodness. In sufficient estimator, this is the requirement. Then parameters should have small variance with small bias. So this is another thing, that parameters are such that variance is very small and bias is also small. We have discussed what is bias and what is variance. Then blue and MSE criteria measure bias and variance of an estimator and make it superior. So in this method, so both blue and MSE, they measure together the bias and variance of an estimator, and that's why the estimator is said to be more superior. Okay, so we'll discuss the blue estimates, best linear unbiased estimates, in our next discussion, and you'll get it also in the PDF little in details. So for today, thank you very much for observing, for watching, and hope you'll go on watching in future, and please share. Thank you.